Hi, and welcome to our final discussion in our electrochemistry unit. This deals with non-spontaneous electrochemistry. In lesson 2, we talked about voltaic cells and corrosion and the kinds of spontaneous electrochemical processes that you should be aware of. Here we're going to talk about the non-spontaneous version, as symbolized by these pennies, these copper-plated pennies. Let's go in and take a look. Non-spontaneous electrochemistry is going to take electrical energy and convert that into chemical energy. This is going to allow us to make redox reactions that don't happen without an input of energy occur in a non-spontaneous electrochemical setup. The most common version of this is what's called an electrolytic cell. In an electrolytic cell, we're going to use electricity to provide the energy necessary to cause a substance to decompose that would not decompose spontaneously. Another term for decomposition is lysis, and so because we're using electricity to carry out the lysis, we get electrolytic cells. This diagram shows the electrolysis of NaCl. Sodium and chlorine are both incredibly reactive and they do not occur in their elemental forms in nature, but we can produce them in the laboratory in an electrolytic cell. Let's take a look and see what's happening here. The negative terminal of our power source provides electrons to the cathode. As electrons arrive at the cathode, molten sodium ions gain those electrons and form liquid sodium atoms with a neutral charge, forming pure elemental sodium. The positive terminal of the power source is connected to the anode, and electrons are drawn from the anode into that positive terminal. As that happens, chloride ions are oxidized into chlorine atoms and form Cl2 gas molecules, giving us pure elemental chlorine gas. Does this make sense? If it doesn't, take a moment and write down any questions that you have before we move on. We can use electrolysis to do some other things as well. This diagram shows the electrolysis of water. It's very similar to the electrolysis of sodium chloride, except that we're splitting up water. In order to do this, we need to add an electrolyte to the water. Sulfuric acid is a typical, commonly used electrolyte. You can see that as electrical current is added, we're producing hydrogen gas and oxygen gas by splitting water into its elemental components. Also notice that we get twice as much hydrogen gas produced as oxygen gas in a 2-to-1 ratio. Our final application of non-spontaneous electrochemistry is in the electroplating of metals. In an electroplating situation, the plating metal is our anode and the object that we want to plate that metal onto is our cathode. As electrons are drawn from our plating metal anode, they move into the power source and atoms of that anode become ions in the solution of our electroplating system. As electrons arrive on the surface of our object cathode, metal ions from the solution gain those electrons and plate out onto the surface of the object, which forms the desired metal coating in the electroplating situation. This chart compares voltaic cells and electrolytic cells. You can see that there are many differences, and in certain aspects, voltaic cells and electrolytic cells are exactly opposite. But notice the one unifying similarity. Oxidation always occurs at the anode, and reduction always occurs at the cathode. Take a moment and look over this chart, and if you have any questions about anything that you see here, now would be a good time to write them down. Thanks so much for watching our discussion of non-spontaneous electrochemistry. Make sure you can do the following things here at the end. Make sure that you can explain how to use an electrolytic cell for separating elements and compounds and for electroplating objects. Also make sure that you can compare and contrast voltaic cells and electrolytic cells. Finally, make sure that you can design electrolytic cells to accomplish specific purposes. If you can do all these things, you're doing great. If not, that's okay too. Take a moment and write down any questions that you have. You can always leave them in the comments below the video, and you can always get in touch with me. Thanks again for watching. I really appreciate it. Have a great day.